Hello everybody, welcome to the Azumuta podcast. This is the first episode in a series of 4 where we focus on one of the topics that has been widely discussed in modern manufacturing and also often misunderstood about dark factories or non-human factories. We will have discussions with business leaders, with experts, with the labor unions to look at this concept from all different angles. Today we want to start with the science of it, so looking at the technological future. And that's why we've invited Professor Francis Werfels and Andreas Verlaenen, who I personally know as the winners of the cloth folding contest for robots some time ago. But I guess you're doing more than just that.
Yeah, today in our lab we focus on all the technologies necessary to create robot helpers that can do everyday tasks in your home or in your company. So that goes from mechanics, electrical engineers, up to artificial intelligence.
Research in AI and robotics, what does that actually mean? Or what are the things that keep you busy during the day and at night?
Well, one sentence, what keeps us busy is research, every research technology towards a robot helper in your home. So it means a focus on electrical engineering, mechanical engineering, and of course AI. And we want to bring those aspects together so that robots can do more tasks.
And with this more tasks, for me in general, it's like giving tasks that humans are currently doing to robots so that humans can focus on things we like to do, like creative things and so on.
To translate that to a factory environment, there's been a lot of talk for decades about lights out or dark factories and things like that. Do you see a difference in how we used to talk or how we used to define dark factories, let's say 10 years ago versus now?
Well, from our perspective, our focus is on, let's say, lower volumes, but high mix of goods. Because then again, this generalization aspect is really important. And so the machine or the robot has to become smarter. And while in the past, in 80s, 90s, the focus was more on high volumes and let's say lesser goods variability. So this becomes more important, and so hence our research becomes more important.
Also, we used to look at how we can change the environment and the task so that it can suit robot technology in order to solve the task, while now we're looking more towards how we can use AI to keep the environment and the task the same, but have the robot adapt to this task.
Does it mean that the definition of a dark factory is different today than it was, let's say, 5 years ago?
Good question. Yeah, actually, honestly, I don't know. From our perspective, dark means, okay, you can be energy saving by cutting the lights and the heat. But from our research perspective, it doesn't have to be that case. So dark doesn't need to be dark, can also be just adapting existing lines, while people can be still around working together with these robots.
Yeah, so that's an important part. Like some people would include a definition like no humans at all close to the robots, hence again changing this environment so that no humans will be around. Well, for us, we generally look at humans will be around. Hence also currently the big popularity of collaborative robots which share their workspace with humans. So.
Yeah, and we of course never look at automation per se. It's a broader, so it's going from automation to general purpose robotics in human-driven context.
Where do you think that people are at this moment overestimating or underestimating the capabilities of robots can do or can't do? You always hear the story about folding a towel that takes ages for a robot to do, or that's what's been said a year ago. I don't know. Are there other more general things that you think of where people expect too much or too little nowadays?
Well, let's maybe first take the towel example. Folding, let's say 10 years ago, Peter Abel was one of the first to do for cloth folding, and it took approximately 20 minutes. Then 3 years ago, we won a cloth folding competition with our lab, where we did folding of towels and t-shirts in under 2 minutes. Today, I think we can even push it towards 30, 40 seconds. But there's an important condition there. And while, for example, our case 3 years ago was focusing on variable t-shirts and towels, you can push it faster, but then the diversity of towels, of clothing types becomes less. But with imitation learning, for example, you can very well train a robot to fold this one t-shirt really, really good. But the question, of course, is can it then fold any t-shirt that's out there in the world? And then that's a good example on how people now think, okay, the robots can do it faster, but an important aspect still lacks, and that's generalization capabilities. And I think in that sense, I don't think we have to expect, let's say, robot butlers, robot helpers everywhere in the world in the next coming year, 2 years, like is promised by many big companies.
Yeah, so the general idea that lives right now by humanoid companies is that we can just plug and play a robot where a human is currently doing something. Hence the big dream of making a robot look like a human, because we are trying to structure the world around us, for humans, for our form factor. And they assume, if we build this humanoid robot, then it can just take over these tasks. But I do think, like in general, that we are highly overestimating what these robots are currently capable of doing, because of the generalization properties that Francis was mentioning. And for us as researchers, this puts a lot of pressure on us, because we are known as a textile cloth folding lab, because textile is a really difficult task. It's like a holy grail task for robots to solve, because if we can solve cloth folding, we can do a lot of other tasks also. So that's the general idea. But we get a lot of phone calls when they see the Tesla Optimus robot on a commercial folding clothes, and they're like, hey, but they can already do this quite well. Well, what's the status? How is your progress going? But then we are like, but maybe if you look closer, you can see that this robot is being operated from a distance by a human in these commercials.
So you basically say robots will won't be able to do every task, especially if they are more complex, and so they will need work instructions to know what to do. Basically, that's at least our premise at Azumuta.
They need working instructions. They also need a way to understand these working instructions, and then also they need to have some kind of training data to learn how to do the task. Or other ways, for example, it doesn't have to be always like imitation learning with these large behavioral models. It can also be just old school but good computer vision together with task planning and motion planning, for example.
And are there specific things that changed in the last, say, 3 years, as so many things changed with LLMs? Are there specific things, technology changes, hardware changes that shifted in the last few years?
Yeah, there are many exciting things, of course. To name one is on the mechanical side. A long time, mechanics had not that much progress, but in the last 2 years, what we see coming up is a lot of anthropomorphic hands at actually affordable prices, which of course enables us as a researcher in longer term in the automation industry to handle more viable goods. Then of course with the advent of vision language models and large behavioral models, we can give, let's say, robots, so to say, common sense, because that's still lacking. Today, a robot can do very good computer vision, can recognize objects, but having common sense, and this glass is full and that one is empty, is way harder to deal with. And that's also something we try to research, because that's what humans definitely have, is a common sense. I have something comes up, the human has to do something. Okay, I cannot do it because I'm lacking this or this components. Robot will not, if it doesn't see it in the past, will not act upon it, and will just try to do the task.
You have a lot of public models, like public models, I mean VLMs and VLAs from Groot and Pi and what have you. Do you use those in your research group, or do you develop your own things? Like, how do you make sure that, like, there are big budgets? Nvidia's budget is I think almost unlimited, and so how do you say, okay, that's what we are doing ourselves, and that's what we are using off the shelf?
Yeah, first of all, our lab tries to identify niches where we can be strong, and one point where we are strong is interdisciplinarity, combining sensing, electronics, making customized fingertips, hands, skins, and leverage that with state-of-the-art artificial intelligence. And on that side, we start from, for example, LBMs or these large VLAs, but then we fine-tune them with local data, often in collaboration with industry or other stakeholders.
But it is true, like, we as a research lab, it might be difficult for us to find the resources to train these very big models. But also, in truth, we knew that for large language models, we needed language as an input to get language as an output. Yeah. For robots, to be honest, it's still an open question. Which inputs do we need? And work instructions will be one of them. But what other inputs do we need to have as output a robot doing actions? Yeah. So it would also be like very costly for us to just try around, train very big models for months, and also collect the data for it. Yeah. So we're more like, okay, but we need to research what type of data we need to collect. Hence why we were focusing on, okay, let's make these fingertips feel multiple types of things, just as a human do. So.
Yeah.
Yeah, and then we can adapt these LBMs so that they can also understand tactility or maybe temperature or other signals from the hands, the skin. And
what are LBMs?
Large behavioral models.
Yeah.
So the, let's say, the ChatGPT models for robots.
Yeah. Okay.
They have their own LLMs, the robots.
Yeah, because you have vision, the actions, and hopefully we are also convinced that you also need tactility and other information.
Yeah. What is your view on using, like, you need to use training data to make those models? I hear, like, the assumption, like, a humanoid modality is useful because we have so much training data on YouTube, and like we have so many examples, and we can also put on a mock-up suit or whatever to generate this example data. So a humanoid robot modality makes most sense. Do you agree, or do you think that's not necessarily the case? It can also be something else?
I would say I tend to disagree, because collecting all that data is still very time consuming. Like large language models, to train these models, there is a huge amount of data available on the web and everywhere. You have digital libraries, you can get data from internal companies. While for the robot, what we still see is someone has to teach the robot by executing the task remotely together with the robots. So that's the dominating trend, I would say, today. And that's just as time consuming, because it has to happen at real time. And the question for us as a lab is, how can we, let's say, reduce the training time? How can we do that more efficiently by adding other sources of inputs, like Andreas said, apart from the video data? Can we add other tactile information, for example? And can we also use other representations and pixels to accelerate the process, for example?
So concerning this data collection, we know that, like, large language models, they have very good performance right now, but they still make mistakes, and we can ask the question, can we afford these mistakes on robots? But putting that aside, if we, like, converse the dataset size of something like ChatGPT and compare it to like the largest robot data set size we have right now. And if we take into account like the data collection farms that are currently running around the world, and these are like all cubicles of people next to each other with a VR, a headset, and these remotes operating a robot. If we take that data collection rate into account and we want to get to a data set size that's like ChatGPT is using, then it's more than 100 years of collecting more data like this. So if we take the current tech and just keep on doing what we're doing now, then I would say we don't have general purpose robots in the first 100 years. So.
100 human years, so you can parallelize it? Or?
Yeah, while we're parallelizing, yeah. So the current data collection rate, if you keep on having the current baseline of like what we're collecting at, the rate we're collecting at, it's more than 100 years of collection. So.
Okay.
And on the other hand, it's very tempting because this becomes also very accessible. So you see many companies, let's say, fine-tuning or training their own small VLA to do a task. But then again, the question is, how does it generalize? To show the robot it has to pour water in a cup, that's easy. And you can train a robot within 10, 20 hours to do that. And even an 18-year-old can do that. But the question is, can it pour in any glass in the world? That's the question.
So while we do have like experiments from like medical sciences where they paralyze like people their fingertips and then see how well they can take a match out of a box and light it, and then they see like success rate of people drops to like 25% because you cannot feel anything anymore with your fingertips, but then you still rely on the sensors you have in your arms and your muscles to do this thing. These are things like currently we are starting in the robot world to take these things into consideration, but hence again, interdisciplinary. It's very important for robots. And the question is, how much are these fundamental research topics taken into account in the current humanoid trend, which Francis is mentioning, just use the same trick as a large language model did.
Do you see that as a part of your teleoperation, so that you can feed back this tactile information back to the teleoperator?
Ideally, we can, yes, so that really a human can feel what the robot is feeling and vice versa. So what's, for example, something that's really difficult for robots to do is opening doors. Opening doors, it's such a tactile thing we're doing. Like we can feel where the hinges are just by the friction we feel in our whole body when opening a door. It would be nice if we have a way when teleoperating this robot we can communicate what the robot is like on a joint level, feeling the resistance on the door. But it's hard to develop these devices.
Because I had the question on like the human robot collaboration, and for training purposes it's obvious, but once in production, for instance, I think you already answered the question, is it like a necessity because the world is like that and you still need that collaboration, or is it more from design that we still want humans somewhere in control or in support of robots?
Well, I think it depends a little bit on the use case. If you have high volumes and simple basic objects or repeating objects, I think in the end the robot can do it autonomously. That can be the goal. Of course, if you have high task variability, high goods variability, then you might want to be able to show the robot this new task without having to go back to the company who developed the robot or the whole setup. One big question, I think, is still, a robot can do 100 tasks. How can you teach the 101st task?
For me, it's really a technical thing also, because I'm not an ethical expert or anything, so I don't know about whether it's a design choice or anything, or at least there are more people suited to answer that part. But like on a technical side, the general premise is that we won't need humans anymore if we have a robot that can do the same things as humans can, which is like our hands are magical, like dexterous manipulation. That's like the thing we're trying to achieve, having the same dexterity and force that we have, and the knowledge on how to operate it as humans can. This is like, we're still very far away from that. So, and we're not going to see that the next couple of years. So we will need this human in the loop to collaborate with, to like the robotist that, for example, does the heavy lifting of an object, but giving it over to a human on a table or whatever, or directly to the human to do more like a dexterous task with their hands, for example. So this human-robot collaboration will remain an important part.
Yeah. Is there any approach of the companies that are developing humanoids, like Unitree, Figure One, Neo, Optimus? Is there a difference in those, and like, do they approach it in a different way? And do you think like, okay, they are approaching it in a way that might be better than another?
Well,
you have a favorite, basically.
We have favorites, of course, but let's say what they all do in common, or all have in common, is a focus usually on humanoids, which I think is a little bit strange, because in most places you don't need legs, for example. It's way cheaper to have a wheeled base. And another focus they always have is imitation learning. So they are leveraging VLAs, LBMs, and trying to push towards that. What differs sometimes is the way how they are collecting the data. So some use their repos. I think, for example, Google has YouTube, so it has access to a lot of human videos. So they are, we don't know actually, but we might think they do it like that. Others, they just use these VR controllers and a VR headset to remotely control the robot and collect the data. Some companies, for example, I was in China in August to a conference on robotics for industry. They even sell this, like this. Like you can buy a humanoid robot together with the VR headset and the remote controllers, so that you can train this robot in your own context. For example, you have a supermarket, small one. Okay, you can train the robot to do that
really?
task. Yeah, and that's their business. It's actually very funny. And then, for example, another example is Sunday Robotics. They recently launched very impressive videos of a wheeled robot helper. Or humanoid robot, you can discuss about that. What they use is the humans. They collect the data with the same gripper as the robot does. So they have like this. Yeah, they don't use the hands of the human, but they have this gripper, the glove, you can say it, with some sensors and the vision data, and that's collected together with the robot. And that kind of makes sense, because the closer you are to the morphology of the robot, the easier the robot can execute the task. And it seems that they also have some nice performance in some household contexts.
A company that used to be a little bit different, but it's actually the company that's been around for a very long time, and most of us know, like, is Boston Dynamics. They built the Spot robot, the Atlas robot, but many more. It's really, they make great technology. Now they have an AI institute around Boston Dynamics, so they are incorporating like imitation learning and also things like reinforcement learning and such. But like a couple of years before this trend, they were more like, oh no, like, we don't believe in cheap robots, so robots need to be very expensive, and we'll put crazy sensors in there, crazy hardware. And they were more like traditional control theory, to control their robots and let it do tasks. Now they are incorporating like modern AI techniques. But just to compare this, like some humanoid companies try to let their humanoid walk, for example, just by doing reinforcement learning, which is different to like how Atlas is running around. So, but they are also like converging. Like now, we think, but once again, it's proprietary. We don't know. But now they use like a combination, probably.
Yeah.
And the same is true for Toyota Robotics Research. That's a lab we actually really like, because they have an interdisciplinary approach, rooting in control theory and mechanical engineering, and expanded that to human and social sciences, to electrical engineering, to computer science, to combine that in a robot helper, and really a helper that can do tasks together with the humans. And that's something I find that more impressive than yet another company just copy pasting tasks.
Yeah. When do you expect us to have a robot helper in our house to do random tasks or the things we don't like to do, so that we have time to do the things we do like to do?
Well, actually, we already have robot helpers, but we just have many tiny robot helpers.
Okay, but like one generic that does all, that can combine all these tasks and
it's always hard to put the data, of course, for that. But I wouldn't.
Do you see that in, I don't know, 3 years or 10 years or 20 years?
Earliest 10 years.
At least a decade.
At least a decade.
Because at home we will need probably legs to walk around, but at this point in time, look at the visuals. Like, you don't want to get close to these humanoid walking robots that weigh like 100 kilograms. And you see it in the videos, they keep their distance, except for when there's like a big table in between. Then they come close to the table where the humanoid is like 1 meter from them. But in general, they try to stay like 2 to 3 meters away from them, because these things, if they fall, they first try to recover by pumping a lot of energy in their legs. But if you get like a robot, 100 kilograms, that's for a couple of milliseconds, putting a lot of energy into these legs, and you get it on your feet, I think you would need a medic at home for.
So. And apart from that, I would say, again, task generalization. Let's take the example of pouring drinks in a glass. In our lab, we are confident we have a very good system that has 99.3% success rate. But there's still this 0.7% success rate where the glass breaks. And then what?
What does it mean?
What does it mean? And of course, we are confident in that number, because and we can deal with any kind of glasses that are used in houses and elsewhere. Most companies, what they show is just one type of glass, or maybe 2 or 3. But okay, and what's the success rate, and what's the generalization capabilities? They are very quiet about that. And then, when something breaks, then what? The robot cannot recover on that. So I think if you would buy a humanoid robot now for your house, you have a lot of cleaning to do.
But so not to catch us on the number, like we think a decade, but we also think like, as a society, I think we will slowly change the definition of a humanoid. Like, we'll probably, given the marketing budgets right now, we'll still call it a humanoid, but they will probably give it, instead of legs, wheels, and they will still call it a humanoid. And so it's also hard to like the current form, like legs and the humanoid hands, which they claim they can do the same thing as human hands, or at least try to achieve. Not the first decade.
And we don't want to be pessimistic. Again, there are a lot of opportunities in what we like to call semi-structured environments, because the house is a total chaos. But there are many environments where there is some structure, like the SMEs, small companies. They have some structure to work there. The same is true in healthcare, hospitals, elderly care centers. They have very similar rooms, similar layouts. So I truly believe that you can mean something in those locations first. And that makes sense. But the household robot, it's still very hard.
So you expect like a more dedicated laundry folding robot sooner than a general cleaning robot in your house?
I expect, or as a lab, we expect that today you have like these wheeled cars which drive goods around in even hotels. If you go, for example, to China, there are also some in Belgium in restaurants already. I truly expect that they will get some arms or some manipulators and do some basic tasks, like maybe cleaning up the table, but not in your house, but in a restaurant or in an elderly care center.
Environment where
Okay. And that's already challenging enough.
Okay.
How do you see open source versus closed source approaches? I know that there are like projects like Le Robot on Hugging Face and things like that collect huge data sets because they are open source, cheap, and do you think that's also an approach that can win, or do you think no, it will be from the privates that have larger budgets?
Well, what I do like about these open source approaches is the same with some YOLO implementations for vision, that they make it very accessible and some, let's say, very creative bottom-up approaches might pop up, because now you see a lot of even school kids working with that. I know kids of 16 years old who bought a Le Robot, an Azure 101, and they use the imitation pipeline and they do creative tasks with that. So that's really interesting because it gives creativity to the people, and we might get ideas from that. But on the other hand, again, the accessibility comes with also sometimes over expectations. Look, my 16-year-old kid can train a robot to do this task. Oh yeah, next year we will have much more in companies. So that's a counter side. And the same I think we saw in computer vision with these deep learning models who became very accessible for basic tasks, but still not all vision problems are solved, I would say. So even there are some difficulties.
The difficult thing with closed source, it's hard to find a moat like around your business model, like to protect your business from just people copying the thing you're doing. It's the same with humanoids now. We have so many humanoids companies right now because you can just copy paste the thing. You can also collect the data. You can use open source models. So when we've seen this thing with language models. Open source was just always a couple of months behind the closed source models. They were not as good, but there's also a business case to make. If you can run these models free locally, privacy-wise more interesting, then it has a place in the landscape. So that's like the really difficult thing, and we're seeing it now with the whole large language models out there. Open source is always catching up, so it's still to see whether this will be true for the robotics models. And we don't know yet, but if it's also the case, then I would think like it forces like companies to make things open source, which I think as a society is a net benefit. But we're academics, so makes sense that we.
Yeah. Do you think there is a difference in of course we are on the SME side and working with factories and working with manufacturing environments. I think our thesis is that those large enterprise manufacturers, they have a lot of people, a lot of data. They will actually have a moat compared to up and coming companies because they have large amounts of training data. Do you think this is true, first of all? And do you think will this be the case going forward, or will the foundational models become good enough that the smaller enterprises can also start using them?
Well, one of the problems is, of course, that data in automation is a little bit similar to like in the field of robotics. There's plenty of data, but nevertheless, it's still not that much data. It's a niche, so to say. If you look at all the foundation models, if you would look up the proportion of data from, let's say, the make industry, it's a very small portion. And so the generalization capabilities to use it in a small company will be limited, and that's why I think it's really important for companies to value their data and their data sources and to leverage that. And I think that's also where we can play a role as a regional entity, or like as Belgium or even Europe. We can maybe put efforts in leveraging our automation industry by maybe combining data sources together, and maybe we have their models trained on that. Because we cannot win on the LLMs, but maybe we can, by combining efforts and on niche data, we can maybe at least have a good foundation model for the automation industry. The same is true for language. We cannot make a large language model for English and reasoning capabilities, but we can make maybe one that handles dialects very well for basic conversations, and that's really useful for our local industry and hospitality. Because, for instance, people in West Flanders, if you would put a robot in elderly care or in a hospital, it doesn't need to speak English. It needs to speak the local dialect. That's what the people want to hear. And it doesn't need to talk in very complex ways and needs a lot of stuff. No, it needs to do basic conversations. And that's feasible, I would say. And the same is true for the automation industry. Maybe you don't want to catch it all, but a smaller niche. And I think we have their data available, high quality data, because we have a very good industry here. So we have high quality data, and maybe you should be leveraging that.
Yeah. If you had a manufacturing factory yourself, would you today already start collecting data, or do you think that's not necessary? The robots are not yet good enough. It can wait.
Well, I personally would have started 10 years ago with collecting the data. Of course, it's a little bit a biased opinion, but I would start. I would feel very late if I would start collecting data now. I think they should and be collecting data, and if they are not yet doing it, they should start definitely now, because that's huge. There's a lot of value there.
Yeah.
Thank you very much. Very interesting.
Thank you very much for all these interesting discussions. For the people watching or listening, with what questions can they approach you? How would you be able to help them? Is there anything you would want to say to them?
Yeah, so as a lab, we are always interested in collaborations with industry. Any company can come to us, especially on problems in robotics and AI, with a focus on, let's say, the manipulation, handling of challenging objects like deformables, glasses, shiny objects. We're always willing to help.
Yeah, we actively also try to put some common sense into the current inflated expectations around robotics, to give like a very clear view on what's currently possible, because there's a lot of new possibilities out there, but it's also what is currently impossible.
Yeah, great. Thank you very much.
Thank you.
See you.
Thanks.
Bye-bye.